Is English your first programming language, and should we start rewriting everything? Imagine trusting software built by a machine that gives you a different version every time you ask. Welcome to the future of programming. The way we write software is changing. With the rise of LLMs, we're seeing a similar shift we could observe moving from assembler to high-level languages. Our attention shifted from details to abstraction. We abandoned shelling out thousands of lines of instructions in the pursuit of micromanaging the CPU. Celebrating our triumph over entropy, we began focusing on structure, on increasing the degree of organization of the system. That shift toward abstraction eventually gave rise to a kind of systems that aren't based on deterministic logic. Neural networks have been around since the last century, with the first commercial implementation in the late 90s. However, they became far more accessible during the 2012 deep learning boom thanks to GPU advancements from NVIDIA. 5 years later, Andrej Karpathy coined the term Software 2.0 to describe the shift toward training neural networks directly with data. Then, in 2020, pre-trained models like GPT brought large language models into the mainstream. Fast forward to this year and Andrej introduced Software 3.0, the idea of prompting LLMs directly in natural language, with a bold suggestion that we might be soon rewriting a lot of code. But let's not rush into rewriting everything just yet. Karpathy's concept of software versioning stems from his work in computer vision, where neural nets and new math models make perfect sense. The same logic doesn't translate well to transactional financial systems, for instance. And for the first time, adoption didn't start with institutions, it started with consumers. Historically, major technologies have flowed from governments to corporations before reaching consumers, just as the internet evolved from DARPA to enterprises and eventually to everyday users. We are still figuring out what AI at scale looks like for enterprises. Some companies went all in, only to hit reality. Klarna, for instance, embraced full AI adoption, then backtracked, firing 700 employees before ultimately rehiring humans. Letting AI generate an entire app might make anyone feel like a programmer. A vibe-coded app built from a paragraph of text and a Figma prototype might seem appealing until it runs into a real-world complexity. Would it be secure? Maybe go ask McDonald's AI hiring bot, which exposed millions of applicants' data to hackers, who just tried the simplest password ever. Thousands of women on the T-dating app aren't exactly thrilled about their data being leaked either. Security remains one of the most complex challenges in software systems, often manifesting only after a cascade of subtle failures. What about the laws and regulations? Yeah, compliance would like to have a word. The lawsuits are rolling in. For example, Disney is coming after Midjourney for copyright infringement. Software architecture isn't just about what the system does, it's also about how it does it. Non-functional requirements like scalability, security, and maintainability shape real-world systems far more than people expect. While great for prototyping, with growing complexity, the context will eventually collapse and you might end up with an inconsistent, rigid content you are too afraid to touch. With the stochastic nature of LLMs, it's the first time we are dealing with a non-deterministic pseudo-random system governed by statistics. In other words, the output can vary with each run. And we are doing this in English, an inherently ambiguous language. The whole point of parse trees in programming languages is determinism, ensuring that a single sequence can't produce multiple interpretations. But how can we utilize LLMs for software development properly? 1. Describe the problem clearly, providing detailed instructions. 2. Iterate in as small steps as possible. You need to follow that generate verify cycle, and reviewing thousands of lines of generated code in one go might not be that helpful. Then again, is anyone actually reading all the generated code? Or are we accumulating cognitive debt as outlined in the MIT study on using LLMs for essay writing? And if so, when would be the right time to pay that debt? Since we are not typing the code, when do we dive deep into an issue and develop an expertise? Remember when we used to memorize phone numbers? Now your contacts and even calendar live on your phone. Bit by bit, we've been offloading our memory and now cognition to machines. Still, machines are great for offloading tedious tasks, like writing unit tests or digging into some framework-specific works that have nothing to do with actually solving your problem. This is something that lowers the barrier for beginners and helps burned-out engineers to rediscover the joy of programming. Think you're missing out by not mastering prompt engineering? Relax. The biggest shift for most of users has been the rise of GUIs. You don't need to copy-paste code from ChatGPT anymore. Most IDEs now come with built-in AI tooling. 2025 may mark the year of AI agents, but even Andre cautiously described them as more of a topic of the next decade. In 2013, driverless cars were just 6 months from becoming a reality. But even today, there's some need for human intervention. We are hitting the limits of hardware. Edge computing hasn't held up well for LLMs despite early expectations. Moore's law, historically stating that transistor density doubles approximately every 2 years, has slowed down significantly in recent years. Horizontal scaling remains the dominant approach. We need to pivot towards innovation. Like in the Hitchhiker's Guide to the Galaxy, we may never build the ultimate computer ourselves. But we may just build one smart enough to create it for us. The next breakthrough would be the integration of quantum computing and artificial intelligence. But that's for another topic. Thanks.